Okay, so concept 0, this is our inclined plane. In fact, this is, let's take a moment to, appreciate just how wonderful this is, right? This is the inclined plane that you get when you order an inclined plane from the scientific catalog, right? And concept 0 here is that the angle we want to talk about is always this angle right here, the angle it makes with the horizontal. So if they give you, like, for example, this angle here, okay, I can't even do it, right? Okay, don't use that angle, use this angle, right? And then concept 1 is that if this is a ski slope, okay, this is a 30-degree angle on a ski slope. And it doesn't look like much here, but does anybody know, is a 30-degree angle very steep on a ski slope? Yeah, that's like a cliff, right? I mean, they make them steeper than that, right? They make them steeper than that, but a 30-degree slope is like, when you're standing at the top of it, looks like a freaking cliff to you. Okay, so do we have sound? Good. It got the freaking too, but I didn't say anything bad. Okay, so concept 1 with an inclined plane is that gravity acts straight down. So if we've got some object on an inclined plane like this with a mass of m, gravity is going to act straight down, and straight down is very inconvenient, and that's because the object can't accelerate straight down, right? It can only accelerate along the plane, or if the plane breaks, it can accelerate into the plane, okay? So when we look at this thing, what we're going to do is we're going to take this weight, which is m times g, and we're going to break it into components like this. And one component goes down the plane, one component is perpendicular to the plane. Yeah? Like that. And we always do this, and the reason we do this is that we want to know what part of the force is acting along the plane, because that's the direction that the object can slide. That's the direction it's going to accelerate. And when we solve these problems, that's what we're going to look at, right? Okay, so this angle right there is also congruent to that angle. And I used to prove that because I really love geometry. But my students don't love it as much as I do. And so that would be like a point where they'd all, like half of them would take a nap, and then I'd have to wake everybody up. So to avoid that awkwardness, since you guys are all talented and gifted, I'll leave the proof of that is left for the student. Okay? And you have to use, I think it's like angles that are complementary to the same angle are congruent, or something like that, right? Isn't that right? I think that's one of them, right? Okay, but there we go, right? Okay, so if that angle, if this is the hypotenuse, this guy's right angles here, right? Okay, if that's the hypotenuse, then this is the opposite side. So the force parallel to the plane is going to be mg sine theta, right? And then the force that's perpendicular to the plane, the force that's holding it against the plane, is going to be mg cos theta. And the reason is, why is that? Because this is the adjacent side, and that's the opposite side. So I'm using SOHCAHTOA. Yeah? Are we good? We're fairly good. We're somewhat good, right? And then, gee, this is not in the data packet. Yes, sir?
Would friction be added to the second?
Friction's going to interact with this guy, right? So as this thing slides down the plane, presumably that mg sine theta is making it accelerate, but the force of friction is acting up the plane, right, and counteracting that, right? Okay, now, these are not in the data packet. You have to memorize these. Yes? But how hard is that to memorize? Well, if you're a spaz like me, it's very hard, because it's like, is it mg sine or is it mg cos? Here's how you remember it. You know it's mg something, right, because mg is the weight, yes? And you know that it's something like that. Here's how you remember. Make the plane level. What's the angle? How much force of gravity is acting parallel to the plane now? None of it is. Which trig function gives you 0 at 0 degrees? Well, sine does. You guys are smart and you paid attention in math class. You know that sine is the y coordinate on the x-axis, so it's 0 or something like that, yes? I could never remember even that, so I took my calculator. This is what a math loser I was. And I go, cosine of 0? Nope. Sine of 0. And I always would guess the wrong one first. I don't know. Right? Okay. So yes. So it's sine. Does that make sense? And right now, by the way, cosine of 0 is 1. So all of the weight is perpendicular to the plane. None of it is parallel to the plane. This is why we make our floors level. Yes. We don't want marbles to roll on our floor. We just want them to stay there. If we put it on there, something that can roll will stay there, right? Yeah? So that's the deal. If the angle is 0, then all of the weight is into the plane. None of it is parallel to the plane. Objects stay, even round ones, stay still on the plane. And then if we tip it up, the more we tip it up, right, the more force there is parallel to the plane, the less there is perpendicular to the plane. If we tip it all the way up, how much is perpendicular to the plane? Yeah, none of it. All of it is parallel, right? It's like it falls. There we go. Right? Okay. So this is sort of interesting in terms of skiing, because if you consider like a really steep slope, steeper, let's make it steeper, right? You're skiing literally on like a cliff, right? Okay. Some object here, gravity is straight down. Most of that force is parallel to the plane. Just a little bit of it's holding you against the plane. Yes? That's fun, except if, of course, if it's an icy slope, you've got to be a really good skier and keep your edges about you, right? Okay. But when is it? How about deep powder? Have you ever skied on deep powder? Yeah, that's when you. So my kids are always, when we go skiing, my kids are always, they'll pick some unlikely ski slope and they'll go, "Dad, would you ski down that?" And the answer is always yes. Give me enough deep powder, and I'm a good enough skier to ski down anything that's steep, right? But if it's sort of icy, yeah, maybe not so much. Not if there's trees around and stuff like that, right? But this is really fun. And there's sort of a weird thing about deep powder. There's a certain range of angles where avalanches are really likely to occur. Too little angle and there's not enough parallel force to cause an avalanche. And if it's too steep, the snow can't pile up to make an avalanche, right? It slides off easily, right? So at above a certain steepness, you can just jump into the powder and you don't have to worry about an avalanche. You can just ski. And it's fun. Here's why it's fun. Think about this. You've got all this force driving you down the hill. How much is holding you against the hill? Yeah, not so much, right? So you're up unweighting, right, is really power. You can just fly through the air, right? Boom and boom, right? Yeah, right? You're very little force holding you against the plane, so you can just fly. You can do all these crazy moves that you couldn't do when you weigh a lot, right? So it's sort of like being a little bit weightless, right? Okay, so all we do basically, the trick to this is that we calculate what this force is. This force always acts down the plane. I'm always going to make down the plane negative and up the plane positive, right? So once you calculate this force, it's just another force that acts down the plane all the time, and then you just look at the problem and you solve it. And it's not really all that hard. Okay, it looks like it's hard, but it's not really that hard. So let's go through. You guys have this note guide, yes? Okay, so I think the example problem that I do, look how fast you're learning, is this, isn't it? Yeah. So let's just go through this and make sure we understand it. And yeah. I'm going to adjust that. There we go. All right. Okay, so here's this inclined plane, and it's 26-degree angles, 5 kilograms. Okay. And the first question says, what are the components of gravity parallel and perpendicular to the plane? We only have to do this once, right? And so let's put that here. So the force parallel is going to be mg sine theta, right? And mg sine theta is 5 times 9.81 times sine of 26, right? So 5 times 9.81 times sine of 26. And if you don't get 21.502, either your calculator is the demon seed, and we need to drive like a wooden stake